In early 1943, deep in the chaos of the North African campaign, a battered M4 Sherman tank fell into German hands. It had been captured during combat in Tunisia and was promptly shipped off to the infamous Kummersdorf Proving Grounds, Germany's top-secret military testing facility, where engineers dissected enemy tech to figure out what made it tick. They expected mediocrity. After all, this was—
If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one.
An American tank mass-produced, boxy, and nowhere near as intimidating as a Tiger or Panther. The Germans had staked their reputation on superior engineering, cutting-edge specs, and mechanical innovation. So, what could they possibly learn from this American workhorse? As it turns out, a lot. What started as a routine evaluation quickly morphed into a low-key engineering humiliation. German technicians, used to dealing with high-performance but high-maintenance machines, couldn't believe what they were seeing. The Sherman didn't just function. It ran smoothly, consistently, over long distances, with minimal fuss. And that's when the realization hit. Germany had never built anything this reliable. Shermans were designed with a different philosophy altogether. They didn't need to be flashy. They didn't need to outgun or outarmor the enemy in every one-on-one encounter. They just needed to work, over and over again, across brutal terrain, in grueling conditions, with mechanics who might have only a few weeks of training under their belts. That was the American advantage. While German engineers had obsessed over performance, precision, and battlefield dominance, American designers had quietly weaponized something else entirely: practicality. One of the first things the Kummersdorf team noticed was the Sherman's drivetrain. It used herringbone gears, those durable, diagonally cut gear teeth designed to distribute stress more evenly and reduce wear over time. These things could operate for thousands of kilometers without failure. In contrast, German tanks were still using straight-cut gears that frequently failed after just a few hundred kilometers. Even in controlled testing conditions, German transmissions were ticking time bombs. And then there was maintenance. German tanks were nightmares to repair in the field. Complex systems, specialized tools, rare parts. Panthers and Tigers often required factory-level attention for routine breakdowns, assuming spare parts were even available, which wasn't a guarantee by 1943. The Shermans, they were built for the field. Standardized components, swappable parts. A mechanic with some elbow grease and a decent manual could patch one up in a foxhole and get it back into battle by sundown. That kind of battlefield resilience wasn't just a perk, it was a game changer. Because while German engineers were drafting beautiful machines that looked unbeatable on paper, Allied crews were actually driving their tanks into combat and keeping them there. Tests at Kummersdorf confirmed it again and again. The Sherman could take a beating. It handled long distances without needing constant attention. Its engine didn't overheat every time the weather changed. The final drives didn't disintegrate under stress. It was like comparing a factory-tuned race car to a well-loved pickup truck that starts every morning and never quits. And that consistency, that's what wins wars. The numbers told the rest of the story. By the end of World War II, over 49,000 Shermans had rolled off American assembly lines. That's the scale of production you get when your design philosophy is rooted in decades of civilian automotive manufacturing. The same factories that built Fords and Chryslers were now pumping out tanks that were simple, durable, and built with interchangeability in mind. Meanwhile, German production was collapsing under its own weight. Panther and Tiger tanks were marvels of engineering, yes. But they were also expensive, slow to build, and filled with components that required specialized craftsmanship. It didn't help that Allied bombing campaigns were systematically obliterating Germany's industrial infrastructure. Critical factories, transportation hubs, even the machine shops that made spare parts, all of it was under siege. Even if the designs were brilliant, the system to support them was crumbling. It's no wonder then that by the latter stages of the war, German units began doing something almost unthinkable. They started using captured Shermans. Because despite all the propaganda, German commanders knew what their engineers had reluctantly admitted: when it came to reliability, the Shermans simply delivered. And for the men fighting on the ground, that mattered more than any fancy spec sheet. German tank crews often found themselves sidelined not because they'd lost in battle, but because their tanks had broken down on the way there. Transmission failures, overheating, undersized final drives that couldn't handle the Panther's weight. These weren't rare incidents, they were routine. Entire battalions of cutting-edge tanks were sometimes sidelined for mechanical reasons alone. The Sherman, still rolling, still shooting, still working. Post-war analysis would lay everything bare. Historians and engineers alike pointed out the fundamental flaw in Germany's approach. They had prioritized battlefield performance and technological dominance at the cost of reliability. The obsession with over-engineering had backfired. What good is a high-velocity gun or superior armor if the tank can't make it to the front line? American engineering didn't try to outspec the Germans. It went with what worked. The automotive industry had spent decades learning how to mass-produce machines that regular people could drive and mechanics could fix. When war came, those same principles were applied to tanks. The result was a vehicle that could be built fast, maintained easily, and operated reliably across multiple theaters of war. In the end, it wasn't just about whose tank had the best armor or firepower. It was about who could field working tanks consistently, over time, and keep them in the fight. Operational readiness became the real measure of effectiveness. And in that category, the Sherman wasn't just holding its own, it was dominating. Even the German military couldn't ignore it. Their own post-war documents acknowledged the advantage. Engineers who had once turned up their noses at the Sherman's basic design were now revisiting it with fresh eyes. Lessons learned from those captured Shermans directly influenced the development of the Leopard 1 tank in the 1950s, a German design that placed a premium on reliability and maintainability, two things they had painfully undervalued during the war. And that, really, was the final twist. The nation that once dismissed American tank design as crude ended up adopting its core principles to build a better future for its own armored forces. There's something almost poetic in that. So what does all this tell us? That in modern warfare, brilliance isn't always the answer. Sometimes it's the tank that starts every morning and keeps going that shapes the outcome, not the one with the best skill stats in theory. You can't dominate a battlefield if your equipment's stuck in a maintenance depot. And no amount of cutting-edge design means anything if it falls apart under pressure. Germany learned it the hard way. And they learned it at the hands of a tank they thought was beneath them. The Sherman wasn't perfect. It had flaws, but it showed up, and kept showing up. In the mud, in the desert, across Europe, it just worked. And when the dust settled, that proved to be more valuable than anyone expected. Thanks for watching. If you're into military tech that actually works, or you just enjoy watching complicated engineering dreams crash into logistical reality, hit that like button, share the video, and subscribe for more wartime breakdowns, literal and metaphorical. And drop a comment. Did the Sherman earn its reputation, or was it just in the right place at the right time? Let's hear your take. American tanks, in their minds, were crude, oversimplified, mass-produced hunks of steel, meant to flood the battlefield, not outmatch it. But as the engineers popped open the hatches, stripped the machine down, and ran it through its paces, those assumptions started to crumble. The Sherman wasn't a fluke. It was intentional. Every gear, every bolt, every panel, they were all designed with one goal in mind: durability in chaos. And that became painfully obvious the deeper the Germans dug. One of the first things that floored them: the sheer consistency of the materials. German tanks often used exotic alloys and bespoke components that varied depending on what was available. But the Sherman, standardized materials, standardized parts. No matter which factory it came from, the build quality was uniform. That wasn't just impressive, it was infuriating to engineers who had spent years trying to perfect vehicles that couldn't survive a cross-country march without snapping an axle or cooking a gearbox. When the Sherman's transmission was opened up, that's when the real shock set in. Those herringbone gears weren't just durable, they were industrial-grade brilliance. Designed to minimize stress and wear, they delivered smooth, quiet operation and lasted for thousands of kilometers. In contrast, the straight-cut gears inside the Panther and Tiger tanks were noisy, fragile, and prone to stripping under stress. And what made that even worse for the Germans was knowing they couldn't implement similar solutions, not without revamping their entire production system. American industry could afford to prioritize longevity because it had the infrastructure to mass-produce complex parts with precision. German industry, increasingly under the thumb of Allied bombing raids and resource shortages, could barely keep its own tanks in working order. Then came the suspension tests. The Sherman's vertical volute spring suspension VVSS wasn't glamorous, but it worked. It was simple, rugged, and here's the important part: easy to repair. American tank crews didn't need engineers with PhDs in mechanical design to keep their vehicles running. Field maintenance was a matter of routine, not crisis. For German tanks, that was rarely the case. A damaged Panther or Tiger often needed to be towed back to a depot or worse, abandoned. Mechanics needed specialized training, rare tools, and spare parts that were growing scarcer by the day. One breakdown could mean weeks of downtime, assuming the tank didn't get bombed on the transport back. And that logistical nightmare. It showed up in every single Kummersdorf test report. Even worse, the Germans documented that inexperienced mechanics, Allied mechanics with just a few weeks of training, were keeping Shermans operational with minimal resources. They had toolkits, replacement parts, and instruction manuals that were actually readable. Meanwhile, German crews were trying to decipher overly complex diagrams, relying on hand-fitted components that weren't even interchangeable between units of the same model. It was around this time that the tone in the German evaluation reports shifted from superiority to subtle panic. The Panther may have looked better on paper with its powerful 75mm gun and sloped armor, but it wasn't a practical machine of war. The Sherman, by contrast, was dependable. And when you're in the middle of a prolonged campaign, day after day, in heat, cold, sand, or snow, that's what wins battles. Operational readiness became the stat that mattered most, and the Sherman was unbeatable in that category. German engineers at Kummersdorf noted that even after long-distance stress tests, the Sherman's drivetrain components remained within tolerance. Final drives didn't crack. Engines didn't seize. Transmissions didn't explode from overheating. That kind of reliability was alien to them. It wasn't just humbling, it was a technological slap in the face. And if that wasn't enough, the real kicker came from the battlefield itself. Reports started trickling in that German armored divisions were, at times, choosing to use captured Shermans. Not as museum pieces. Not for propaganda, but in combat. Because they needed tanks that could actually get from point A to point B without breaking down halfway. And as far as mechanical longevity went, the Sherman was doing circles around the best that Nazi Germany could produce. It wasn't even close. And let's talk about production numbers. The Americans built over 49,000 Shermans by the end of the war. That's not just volume, that's scale with purpose. Shermans could be deployed, maintained, and replaced at a rate that the Germans simply could not compete with. Allied supply chains, built on civilian logistics experience, kept tanks moving and fighting. Meanwhile, the German tank program was collapsing under its own weight. Tigers and Panthers, when they worked, were terrifying. But they broke down so often that some German commanders openly complained they were more of a liability than an asset. Strategic bombing only made the situation worse. Manufacturing plants were reduced to rubble. Supply chains were strangled. The highly specialized components required to build or repair German tanks became rare luxuries. No matter how advanced the design, it didn't matter if the thing couldn't be built or fixed. And that's where the Germans had to face a brutal truth. American industry didn't just win the war, it buried them under a mountain of functional hardware. The post-war world took that lesson to heart. In the 1950s, when West Germany began developing the Leopard 1 tank, they didn't chase after ultra-heavy, over-engineered designs like the Tiger II. They went in a new direction: mobility, maintainability, and reliability. That shift in thinking was a direct result of the painful lessons learned during World War II. The Leopard 1 wasn't just a better tank, it was an apology letter written in steel. So what's the takeaway here? It's not just that the Sherman was a solid tank. It's that the Sherman represented an entire mindset, one that valued function over flash, consistency over complexity, and engineering with purpose over engineering for prestige. Germany poured its genius into tanks that couldn't keep up with the logistics of modern warfare. America poured its resources into tanks that could be driven, fixed, and redeployed with relentless efficiency. And that difference wasn't just strategic. It was philosophical. In the world of armored warfare, every glorious specification becomes meaningless if the tank doesn't start, or if the final drive cracks, or if your entire maintenance team has to drop what they're doing for a 3-day gearbox repair. The Sherman avoided that trap. German tanks fell into it, face first. The Kummersdorf reports one secret. Now historical footnotes tell that story in black and white. They reveal how German engineers, after opening up and testing the Sherman, had to admit the uncomfortable truth. They had never built anything so mechanically dependable. Their tanks may have been masterpieces, but the Sherman, it was a machine of war. And when the dust of battle settled, that was what really counted. It's kind of poetic, isn't it? The very thing the Germans dismissed as inferior to simple, to basic, to American ended up being the mechanical backbone of the Allied advance. While tigers roared and panthers stalked through war documentaries and history books, it was the Sherman that actually got the job done. It may not have had the sex appeal of a German super heavy tank, but it could be counted on to show up, roll forward, and keep fighting. And that's the part that tends to get glossed over in the midst of World War II armor. Everyone loves the underdog story of a lone tiger taking out 5 Shermans in a single engagement. But they forget that 10 more Shermans were right behind those 5, and all of them had fuel, working transmissions, and spare parts in the back. You can't win a war with broken machines, no matter how good they look in a museum. German engineers weren't oblivious. They knew what was happening. They saw it firsthand at Kummersdorf. The numbers didn't lie. They were watching a tank built by car guys with decades of civilian production know-how outperform their hand-tuned mechanical beasts in the one area that mattered most: reliability. And that reliability translated into operational presence. Sherman units stayed on the move. They weren't just pieces on a map, they were active, constantly repositioning, pushing fronts, supporting infantry, holding ground. Panthers and tigers, when they did show up, often had to be treated like glass cannons. Too many broke down before even seeing combat. Some didn't make it out of transport. Others failed during retreats, abandoned and blown up to keep them out of enemy hands. Think about that. The Germans were blowing up their own tanks because they couldn't keep them running long enough to escape. Meanwhile, Allied commanders could rely on Shermans not just to fight but to endure, to absorb damage, to be fixed and sent back out, over and over again. And here's the irony: the Sherman's reputation has often been unfairly flattened by the myth of the superior German tank. But when you strip away the romanticism, the brutal reality of warfare doesn't reward complexity, it punishes it. War favors what works, what lasts, what can be fixed with a wrench and some determination. So yes, Germany had the edge in mechanical sophistication. But the US, it had reliability, logistics, and sheer industrial momentum. That's what rolled through North Africa. That's what pushed into Italy, through France, and across the Rhine. And in the end, that's what helped win the war. Thanks for sticking around. If you've got thoughts on the Sherman versus German armor debate, drop them in the comments. I want to hear what side you're on. Don't forget to hit like, share this with someone who still thinks the Tiger was invincible, and subscribe for more breakdowns of history's biggest mechanical showdowns.